Hey, what are those lights?
Look at them. You'll remember.
That is pretty cool.
Scientists use LED lights flashing at 40 Hz to cause gamma oscillations in the brain that could help develop a new treatment for Alzheimer's. The Mayo Clinic defines Alzheimer's as a progressive disease that destroys memory and other important mental functions. Alzheimer's is the most common cause of dementia, a group of brain disorders that results in the loss of intellectual and social skills.
The results in this paper were obtained through experimenting on mice that were bred to develop sticky brain plaques and tangles, which are thought to be the cause of Alzheimer's disease in humans. Human trials are pending.
48 million people worldwide are affected by Alzheimer. As of now, there is no known cure, and treatments often offer little relief of symptoms. If gamma oscillations can help create a treatment, it would be a first real step forward in helping those afflicted by Alzheimer's. Even if this research doesn't directly develop a treatment for those suffering with Alzheimer's, it sheds some light on how to activate the brain's immune system, and that could be used to fight the disease in the future.
Microglia, the immune system cells that act as macrophages in the central nervous system, can be externally activated by creating gamma oscillations. Activation of microglia is done by flashing an LED light exactly at 40 Hz, so the light produced by the LED is seen by the subject. This causes neurons in the visual cortex to be activated at the same frequency. The microglia then activate and begin to break up and absorb the sticky brain platelets and tangles. Scientists at the MIT Institution for Learning and Memory said that they observed almost twice as many microglia in the 40 Hz group when compared with the random control group. This activation can be seen after just 1 hour of the flashing light treatment and lasted for a full day. Mice given a week of daily sessions of the LED treatment had 67% less clusters of amyloid proteins than mice who did not receive the treatment. The clusters that were observed in the mice who received the treatment were also 64% smaller than the control group's mice clusters. While these reductions of clusters were only seen in the visual cortex, the authors believe that the treatment might cause wider-reaching immune-boosting effects in humans. This is also possible that an alternative delivery system could be devised to extend the effect into the brain regions that are affected most by Alzheimer's, such as the hippocampus.
The mechanism of Alzheimer's disease is an accumulation of proteins called beta amyloid and tau within the brain, resulting in plaques and tangles. Beta amyloid proteins will clump, causing plaques which block signaling and communication between the cells, triggering immune reactions causing the destruction of disabled nerve cells.
Tau will collapse into tangles, blocking nutrients from reaching nerve cells, leading to cell death. Plaque and tangles will begin in the hippocampus and will progressively spread throughout the brain. The stage of the disease is dependent on how far the plaque and tangles have spread. Current treatments for Alzheimer's disease include medications that attempt to slow its progression, but has no actual effect on curing the disease.
Neuroscientists have demonstrated that microglia, or immune cells, play a key role in the brain's cleanup and can be activated by inducing rhythmic electrical impulses in the brain called gamma oscillations. This is done by setting LED lights to flicker at 40 Hz, which is undetectable to the human eye. After the mice were subjected to the light for an hour, scientists found reduced levels of amyloid protein in the visual cortex and detected a noticeable increase in the activity and size of the microglia. This suggests that the immune cells were vacuuming up and taking out more trash. When mice were given this treatment daily for a week, they showed 67% fewer amyloid plaques, and the plaques were on average 64% smaller. Although it has not yet been tested on humans, scientists are hopeful that in the future the light therapy will lead to induced gamma oscillations and that the immune-boosting effects will extend to regions of the brain, such as the hippocampus, which is profoundly affected by Alzheimer's.
That's all, folks.